Right, so let me show you around the test setup that I'm running here. Now, just a quick forewarning, this is not a scientifically accurate test. When you change a motherboard over, there's a million different variables that can change at the same time. For example, this particular motherboard has a performance enhancement feature, which I've got disabled at the moment, which can extend the amount of time that a CPU will stay at maximum boost clocks. So straight away, that would give this board an advantage over a motherboard that was not fiddling around with the boost timings. However, I will be doing my best to try and leave all of those features turned off and just stay with just stock settings, XMP memory, and a 1500 MHz fabric clock. And that should give us a reasonable amount of control in these tests. This is not about how fast can we make the 3950X go. This is more about looking for outlier numbers that show one of the other motherboards being demonstrably unable to run this CPU at maximum speed. So the actual numbers that I'm watching, if I switch over to hardware info, these numbers are very small on the screen, so bear with me. You'll have to take my word on what they say. But the numbers I'm looking at is from hardware info here, I can see the CPU temperature, I can see the CPU clock speed, so what kind of boost clocks we're getting. I can also see how many watts that the CPU package is pulling as a total, and also how many amps it's pulling at a total. The other numbers, so the numbers I'm looking for are, I want to see higher temperatures or abnormally lower temperatures, package power being abnormally higher or lower than usual, and also I want to see if the boost clocks are hitting what we expect them to. So if we run this test on one of the other boards and we see that the CPU is consistently running at a lower boost clock or is pulling consistently lower power, that will be standing evidence that the CPU is not getting as much power as the ROG Strix can deliver. So that's what I'm going to be looking out for. Finally, to actually measure temperatures of the VRMs, I've got a K-type thermocouple hooked up, tucked in under the main VRM heatsink. So on the Asus motherboard here, it's currently telling me about 46 degrees. And if I stick a infrared thermometer on the top of the heatsink, that gives me about 45.5 degrees. So as you can see, we've got reasonably accurate temperature monitoring at the VRM heatsink here that's giving us a rough idea on what we're getting. And it's slightly hotter at the base of the heatsink than it is at the top, which makes sense. So once again, these are not super accurate numbers. Some motherboards have got temperature probes that you can read directly. Some of them don't. This particular motherboard doesn't, and I doubt the others will have either. However, using a thermocouple, we can get a rough comparison between them. So, as I say, not a super scientifically accurate test, but it should be good enough to demonstrate the problem that we're trying to show. So now what I'm going to do, I'm going to carry on leaving Cinebench R23 on loop. In this case, this one's been running for just over a quarter of an hour. I'm going to let it have at least 20 minutes so we know that everything is as hot as it is likely to get. And then after that, I'm going to swap it all over to the next motherboard, run the tests again, and we'll see if there are any outlying figures. Just for fun, just for the last 10 minutes of the test after the 20-minute runtime, I just stuck a big 120mm fan over the top of the VRM heatsinks just to see how much we could slash from the temperatures with active cooling. And the answer to that is 17 degrees in this instance. So it just goes to show that having active cooling on the VRM can massively improve the cooling on it. Now this motherboard doesn't particularly need it because the temperatures we got were just fine. However, it does demonstrate that having any kind of airflow over your VRM heatsinks will make an enormous difference. So, worth keeping in mind. This might become very relevant later on in the tests. And we're off with the Gigabyte X470 Gaming X. So this motherboard is an interesting one because it's a board that I've had kicking around the shop for a while now. And it's Gigabyte's answer to what's the cheapest X570 motherboard money can buy. And this was their answer to that. And it's got a surprisingly capable VRM, considering it's the cheapest X570 motherboard that they could make. However, everything else about this motherboard is soul-crushingly dull. It's got a crap rear I/O. It's got crap audio on it. It's got crap USB options because there's no Type-C connector or anything like that. Although it does have two 3.0 connectors on it, but whatever. So the reason why it's sat around my shop is that every time I've gone to build a computer, I've sort of taken this board out and been like, no. So I don't really know what to do with it. However, it will be very interesting to see how well it performs in this test. Now, I had to leave Gigabyte's core performance boost turned on in the BIOS for this one, because without that, the CPU seemed to be locked to 3.5 gigahertz, which was clearly not right. It was not boosting properly. And that wasn't a power issue, that was just a configuration issue. So it's possible that this one may give higher peak boosting at the moment. So if we have a quick look at our sensors, our peak boost has come in at 4.3, or there's a 4.6 on core 0 there. So we may have had some slightly higher peak boosts, or it may have boosted for slightly longer than it did on the ROG motherboard. However, at the moment, our typical clocks while running Cinebench, we're coming in at around 3.9 gigahertz, which is the same as what the ROG motherboard was giving us. So I'm fairly confident that core performance boost or no, we should be getting very similar numbers here. As an interest thing, this motherboard does actually have a VRM thermometer on it. It's got a temperature sensor at the MOSFETs, which is currently reading 65, while my thermocouple reads 55. So from that, we can theorize that we're likely to see about 10 degrees higher at the chip itself compared to where I've managed to get my thermocouple into. And that's completely possible. So we could probably estimate that the same thing was the case with the ROG motherboard, the B550F. We were getting a maximum of sort of 45 to 47 degrees there. So at the chips, we were probably seeing about 55, 57, that kind of area. This setup has been left to run now, and we have slowly crept up to 61 degrees indicated by the thermocouple. And on hardware info, if I scroll back down to our VRM temperature probe, we can actually see that the VRMs are running up at 70 degrees now. We have seen peaks of 73 degrees too. So these guys are getting pretty toasty. Now 70-ish degrees, that's still within the maximum operating temperature of MOSFETs. However, here's where it gets interesting. If I go up to the CPU clocks, while we're running Cinebench on loop, when we started out, we were getting about 3.9 gigahertz all core, whereas now we've dropped down now and we're actually running at about 3.85 or so. So we're getting 3.4. So we're getting 3843 and 3868, and we're kind of bouncing between that. Whereas previously with cold VRMs, we were at a rock solid sort of 3.9, 3917, that kind of number. And once again, if I stick the fan on here, and if we cool those VRMs down with some active cooling, let's see what happens to that. So I'll give this a couple of minutes just to bring the temperature of those VRMs down. And like with the Asus board, I'm expecting this to slash 10 or 15 degrees out of those temperatures. So we'll wait for those temperatures to come down again, and we'll see what those boost clocks look like. And there we have it. Now we've got the temperature of the VRMs down to 49 indicated. So that's going to be about, 60 degrees or so at the chip. We're now seeing boost clocks back up at 3.917. Dropping a little bit to 83, 93 here and there, but generally looking for a solid 3.9 gigahertz. So this is very interesting, and I didn't expect to see this on this board. I thought we were going to have to go down as far as the MSI before we started seeing real results. However, this has conclusively proven that this board cannot drive the 3950X at full tilt for long periods of time. We're losing a little bit of clock. We're talking 50 megahertz here, which is arguably nothing. However, and also we are talking stability torture test scenarios here. There might be some more stronger tests than this. There's probably going to be someone who'd be like, oh, you should have run Ada64 or something like that. You know, there's probably some tests out there that may even make this even worse. If you're running on the desktop or if you're in games, you're not going to see this. However, this does prove that in a practical test here, we have managed to make the CPU run slower by throttling the power it can get from those VRMs. And as it comes down, you know, just looking at those clocks, I'm also seeing little flashes of 3950, you know, 3942 and so on. So we're potentially seeing a droop in clocks of 50 to 100 megahertz or so. So this isn't very much. And, you know, we are having to go to very extreme cases to demonstrate this. However, it does prove that the lesser VRM on this motherboard is actually struggling to supply the 3950X at full tilt. And we're not overclocking here either. This is just stock speeds. So this proves that the big beefy VRM on the Asus board is actually more capable than this and will bring out more in the CPU. Let's go down to the MSI, and hopefully, if this holds true, be quiet. We should see an even more extreme example of this. So I'm going to pull this all apart. We're going to change over to the next motherboard. Alright, we're now nearly 10 minutes into the test on the Msi X470 Gaming Plus Max. So this is the board where I'm expecting to see it all go wrong. So things of note, this board had smaller heat sinks on it, and the only place I could get my thermocouple was right in between the MOSFETs, which is actually giving me a much more accurate temperature reading. The software probe is indicating 63 degrees right now, and we've got 60 on the multimeter. So keep in mind that this is actually reading slightly hotter than it was on my previous ones, where I was out at the edge of the heatsink. You know, the funny thing is, we're over halfway into the test. The VRMs are past 70 degrees now, which is where the Gigabyte board was having problems. And our boost clocks are actually still a shade above what the Gigabyte was giving before it had problems. We're looking for 3.925, which is kind of odd. And like I just saw 3950 on a couple of cores as well. So weirdly, despite this being what should be the weakest board, so far it's doing fine. It's the weakest board, the VRMs are running the hottest, but it doesn't care. Well, we're 20 minutes in. The VRMs are up to 77 degrees. But they're still hitting their max. I think they could go a bit higher, but it's had the same 20 minutes as everyone else. And if we roll up to our clocks, let's see, it's just starting another cycle. Ooh, they've just started drooping. Well, no, there's 3925 again. It's fine. It's still fine. It doesn't care. It doesn't care. The VRMs are on fire. Ow! The VRMs are on fire and it doesn't care. I tell you what I'm going to do. In the interest of science, I'm going to leave this to run longer and just see how hot those VRMs will go. Another 10 minutes later and we've got 80 degrees, but we're not cracking 81 at all. Every time the test starts another loop, it just dips to 79 and then clicks back onto 80 again. I think if I left it for like another 10 or 20 minutes, we might get 81, but I think this is as hot as it's going to get. So now I can point a fan at the VRMs and the temperature on them will tank, but that doesn't tell us anything at the moment because we're not seeing any drooping clocks. But what I will do as an interest thing is I'm going to try and simulate this being in a case by putting the case fan, putting this fan at the back in an exhaust style. and we'll just see what that does to see if this would do anything else if it were in a chassis. Let's see if we can get that mounted. So if that was there, and we were in a case with a case fan at the back, would that make any meaningful difference? We've certainly got some warm air coming out the back. Yeah, there we go. After a couple of minutes, however it's whatever the timer says, after a couple of minutes of having the fan at the back simulating being in a case with a case fan, we've now scrubbed, let me see, we've taken 5 degrees off of the VRMs, and that would probably go down further given time. And this is just with a case fan at the back. This fan is not on high speed, it's on whatever the default fan curve for this motherboard is. And also, this is assuming that there's no real incoming airflow from the front of the case either. So, yeah, even the slightest amount of airflow around the VRMs will help. It's not as effective as pointing a fan at the heat sinks because they're kind of too sheltered, really. But just a slight amount of airflow does help. There's 74 degrees, so they're still, you know, they're potentially still coming down. Yeah, well, I would say that's disappointing, but I don't have a horse in this race. It's not in my interest for any of these boards to fail or succeed. But I tell you what I am going to do. I'm going to test the Gigabyte again. I'm going to test that one again, and just like I'm going to go over the BIOS settings on that and just make sure there wasn't something dumb set up in there, that I didn't just get something wrong, because I can't understand how the X470 Gaming Plus with its poxy underbuilt VRM that's running at 80 degrees is clocking higher than the X570 board with 10 phases on it. Like, what the hell? Yeah, on the ring test, same result. MOSFETs are reporting 70 degrees in hardware info, which is not enormous. MOSFETs are fine with 70 to 80 degrees. A lot of MOSFETs, the thermal max is like 110. So, you know, 70 degrees shouldn't be an issue here. And remember, the MSI wasn't even blinking at 70 degrees. So 70 degrees, and our core clocks, they have settled down at 3843, 3868, well below 3.9. Now, again, these are very small differences here, but we are talking nearly 100 megahertz at the maximum borders here. So, yeah, this is not the result I expected at all. I thought this would be the other way around. I thought we would see the droops on the MSI board. The MSI board was running hotter, but it didn't care. Whereas these guys, these are not putting out as much heat that the MSI was, yet we're actually seeing a visible drop in performance. And one more time for the class, let's point a fan at those VRMs, and you watch, the clock speeds will come back up again. Let's get a fan in there. I'm going to give that time to come down because it's going to take a couple of minutes. Again, this fan is not on turbo speed. I've just plugged it into the CPU fan header, so it's just doing whatever the default CPU fan profile is. And our CPU is sitting at a easy 49 degrees at the moment. Right, couple of minutes with the fan on the VRMs, and we brought the VRM MOSFET temperature right down to 57 degrees now. So we've taken that from 71 down to 57. And if we roll up and take a look at our clocks, we're now seeing, again, we've got 3893. There's a couple of them looking for 3917. So still slightly lower than the MSI motherboard, but again, we've got to think about power draw and stuff like that. There's going to be slight discrepancies. The important thing is that we've seen that the clocks have gone up a bit as the VRM's temperature has come down. There's a direct correlation here between VRM temperature and our maximum all-core boost clock. So this isn't the result that I expected. I kind of want to say it's not the result I wanted either. I wanted to see a really nice clear indication that as we went down through tiers of VRMs, we saw a strong match in the performance of the CPU. But actually what we seem to be seeing here is that the VRMs on this motherboard are actually not very good, and the apparently trash VRMs on the MSI board are completely fine. But that's not the full story, because this doesn't account for overclocking. When we try if we try overclocking the CPU, we might see very, very different results. Under overclocking scenarios, we might see that the higher built VRMs on the Gigabyte and the Asus ROG motherboard have no issues getting modest overclocks on this 3950X, whereas the MSI board, as soon as we try and overclock it, it will just be like, nope. All of the nope, can't do it. But the problem is that I am really short on time, because this is not my CPU and I need to put this CPU into someone's computer. So I think I'm out of time for this test. But what we are seeing here is that maybe VRMs, certainly at stock speeds, might be not as important as people think. Don't get me wrong, good VRM is great, and if you're overclocking, it's even better. But at stock speeds, doesn't seem to really matter. That's certainly what I'm getting from this. Right, I was going to quit at this point and just post up what I had and go, here's an experiment I ran, make what you will of it. But I wasn't really happy, because this was supposed to be an educational video and it wasn't really giving any kind of useful conclusion, in my opinion. So I've just jammed in an overclock on this thing. I've gone to 4.2 gigahertz all core locked out. So instead of letting Precision Boost do the work, I've just gone 4.2 flat. Now, Ryzen overclocking is squicky, and remember, this isn't like overclocking in Intel. With Intel, you just jam in all of the multiplier and you add in voltage as required. Ryzen is more complicated than that. So this overclock doesn't necessarily mean it's going to go faster. It's more complex than that. However, what we should see is that it starts drinking more power. So let's see if that holds true. So let's wind this up, 30 minutes, start test. And let's see how it handles this. So where's our controls? Our core voltage, that's dropped slightly. There we go. Our CPU package, we're now at 200 watts. So we have now massively increased our power draw. Previously, we were sitting at about 130, 135. Now we're at 200. So let's see what this does to our temperatures. So the two things I want to know now are, what does this do to our VRM temperatures? Now they're having to do significantly more work. And does it stay stable for the 30-minute runtime of this? Now, the results that I'm looking for now are that this board can manage this, but the MSI won't manage it. That's the result I'm now looking for. Let's see how we get on. We're also getting a little bit more airflow from the radiator, just because the CPU temperature has skyrocketed, because we're pumping in more voltage. I am not going to be doing lots of these tests because this ain't my CPU. Right, okay, let's see how that goes. We're 10 minutes into this run now, and I am going to bottle out at this point because this is not an overclocking adventure. If I was actually doing some overclocking and I was actually looking for big benchmark numbers, I'd be sticking a fan on the VRMs. However, that's not what this video is about, so I don't want to thrash everything right now. The VRMs are up to 91 degrees, so they're starting to get pretty toasty now. Now, if you are actually running this, thing flat out and you were going for overclocking, you would have case fans on this and you would be giving it some help. I'm not giving it any help at the moment, so I'm not going to thrash it. But it bears mention that because we're locked out at 4.2, our clocks are not dropping, and we are seeing CPU package power draws. We've seen 228, so just shy of 230 watts. So as you can see, although this guy seemed to be slowing down a bit at stock speeds, but when we actually forced it to go faster, it was more than capable of doing that. Let's run the same test on the MSI, and let's see if the MSI's little 4+2 setup can keep up with this now. This might be where it gets interesting. Back on the MSI board now, and we're less than 2 minutes into the test, and our VRMs are up to 63 degrees and rising, 65 and rising. So it's a question of how high I'm going to let them go before I bottle out. I'll let them go. Yeah, I mean, let's see how high they go. Because the problem is that I know these guys are going to get toasty. I'm kind of hoping it crashes before it gets that far, or something happens. All right, we're not 10 minutes into the test yet. We're about, we're 7 minutes in or so, and the VRMs are hitting 100 degrees C. I am not willing to break this motherboard just for the sake of a video. So I'm going to put a stop to that. That's enough of that. Okay, fine. We're going to run the test around on the Asus as well. I'm going to see how the ROG Strix does. Same test again. We'll see what temperature that gives. And then I think it's time for conclusions. ROG Strix is back on the table again now. So this motherboard didn't have the VRM thermal sensor, so I've rigged up my multimeter once again. I've made sure that the probe now is nestled right between two of the power stages. So it's going to be a little bit off from the actual power stage temperature, but I'm hoping that we should be within 5 degrees or so. So at the very least, we could probably add 10 degrees onto this indicated temperature and definitely have a worst case figure. So that's where I'm going from. Once again, we've got the same overclock dialed in, 4.2 with any performance boosts enabled, although they probably don't matter because we're locked at 4.2 gigahertz, and again, 1.4 volts. 1.4 volts again is probably a little bit on the high side. Wouldn't recommend running this long term without knowing an awful lot more about what you're doing. However, for the quick and dirty tests we're doing at the moment, it's good enough. Again, our CPU package draw, we've had peaks of 137 watts here. So again, we're a good 100 watts or more over the stock power draw now. So this is a much, much truer test. And so far, well, we're sitting at 35 degrees, so maybe 40, maybe 45 if you're lucky. Let's leave this to run and see where it goes. We're now 25 minutes into the test at the full overclock and everything. And as you can see, our indicated temperature is 58 degrees. Now, I think that we're actually about 5 degrees or so higher than that on the MOSFETs themselves, but let's assume that, like before where I was reading from the edge and we were seeing about a 10 degree difference, let's pretend that it's 10 degrees because that's our worst case figure. So even if we're 10 degrees out, we're still just below 70 degrees. And if you remember back, the Gigabyte board, that was looking for 93 degrees about 15 minutes into the test. And the MSI board, that was hitting 100 degrees 10 or 15 minutes into the test, and I had to put a stop to that. This could do this all day. There's not a doubt in my mind. That's topped out. That's not going any higher. It's been stuck on 58 for about 10 minutes now, and I've been waiting to see if that's going to crack 59 or 60, and we still have not. So at this point, that is as hot as it's going to get, and we haven't even got any active cooling over here either. Again, in a case or in any sensible setup, you would have some case airflow just to provide a bit of wash. We've got some coming from the radiator because the fans are going like the clappers at the moment, but that's the same that the other boards had as well. So this is a demonstration on how the ROG Strix board with its smart power stages is absolutely superior. But it is still interesting that the other boards managed the same overclock. So let's turn all this off and pack it away and get to the conclusion. So Those tests didn't exactly go how I expected them to. And I don't know how I feel about all of this. Really, I think there's more testing that would need to be done to give really conclusive results. However, by all accounts, what we learned from those tests that firstly, at stock speeds, really, your VRM doesn't make a huge amount of difference. All of these boards are designed to run the CPUs that are on their support list, and they can. We found that all three motherboards were more than capable of running the 3950X under full load for long periods of time without any serious drop in performance. We did see a tiny little bit of drop-off on the Gigabyte X570 Gaming X. However, this was really difficult to conclusively prove. It looks like we had a strong correlation between the VRM temperature and a slight droop in boost clocks. However, it's difficult to really say if that was just the fact of, in this board, it wasn't really boosting as hard as it could have done anyway. Like, just based off the bat, the Msi X470, this was giving slightly stronger boost clocks just across the board than the Gigabyte was. So those differences, it's difficult to say whether that was the VRM or not. It did go down slightly when the VRM was hot, and when I cooled the VRM down with a fan, it went up ever so slightly. So that to me looks like the VRM was having a little bit of a moment. But the thing is that AMD Precision Boost Overdrive is a really weird animal, and it's very much opportunistic boosting. So it's entirely possible that a little bit of fettling in the BIOS would have ironed that out anyway. So while we did see some results there, I don't want to draw any conclusions from that, because I don't think any of those were strong enough to really say, okay, this board is terrible. But it does bear mention that this board was consistently performing lower than the other ones were. Make of that what you will. What I expected to see was for this board to just crumble under the load. I expected to see this one to go way up into the 90s and for those boost clocks to start dialing back as the VRMs failed to deliver enough power. However, that didn't happen either. The ROG Strix, of course, had no worries. So basically what we found was if you have a 3950X, you can run that in any one of these motherboards, despite the fact that if I sold someone a computer with a 3950X and this motherboard, I'd probably get panned in the comments. I'd certainly question someone else's motherboard choice if they told me they were buying a 3950X and one of these to run it. I'd be like, oh, really? But at this point, I can't see a problem with that. However, when we went on to the overclocking, the picture did change very significantly. Under overclocking conditions, we saw that, firstly, both the Gigabyte and the MSI motherboards, the VRMs started running a real toasty on them. We went from a approximately 130 watt load up to a 230 watt load, and that really changed the dynamic of things. The Gigabyte X570 Gaming X, it was managing it. It took longer for it to get up to problematic temperatures. Again, theoretically, the VRMs are good for over 100 degrees, but you don't really want to be there. You don't really want to be running everything at the red line all the time, because that's just going to shorten the life of it. So it's not ideal. However, it took longer to get there, and if you had any kind of cased airflow, it's entirely possible that that would be manageable. If you had an exhaust fan at the back and an exhaust fan up the top, just bringing cold air to those VRM heatsinks, it's possible that it would have been quite happy to sit at those temperatures, no problems whatsoever. And again, once we locked off clock speeds, we weren't seeing any droops there anyway. The MSI, however, that was sailing up to 100 degrees within a very short space of time. Like within 10 or 15 minutes, we were up past 100 degrees under the overclock conditions. And while it's quite possible that it would have stabilized, or again, if we had some airflow to those heat sinks, we would have been able to manage that. That seems like a recipe for a short lifespan on the motherboard to me. That sounds like this motherboard would have gone pop within days, weeks, months to years, who knows. However, you don't want to run your motherboard VRMs long term at 100 degrees. That's not a good idea. They're not going to last with that kind of load. And then finally, the ROG Strix with its big, beefy 14 phases of power stages. This guy tanked the full overclock conditions without even breaking a sweat. We were looking at a maximum of 70 degrees there, and that was after a good 25 minutes going on half an hour of full load. And we were trying to get 70 degrees. So that demonstrates that the high-built VRMs on here are really capable. And if you were actually going to go for a daily overclock, if we were going to leave this running daily under those overclocked conditions, running under load, or if we were actually going for some competitive benchmarking, if we really wanted to give it the beans, this motherboard would easily be capable of it. Whereas these motherboards, sure, they could probably do it, but you're going to be sitting there worrying if your VRM is catching fire. And when you're overclocking, you don't want to be thinking, is my VRM giving enough juice? That's not what your concern wants to be. So, as I say, not the results I was expecting. I was kind of expecting to see a nice, simple 3-tier of motherboard. If we swap these over, I was expecting to see a nice, best, good enough, not capable. That was the conclusion that I set out to get to in this video. I was aiming for that. However, what the test showed were at stock speeds, any one of these motherboards would be absolutely fine. And under overclock conditions, this one is basically a no. This one, with some cooling assistance, yes. This guy, no problem at all. So that was a bit more conclusive. We are currently entering a phase where people are valuing high performance over efficiency, or rather, that's where the industry has gone. When you look at setups like, the more modern Intel chips and also like the NVIDIA RTX 30 series, everything is getting really power hungry right now. And whereas a couple of years ago I was saying kilowatt power supplies are stupid, these days I'm finding myself saying to people, yeah, you kind of want a 750 or an 850 just in case, because if you want to load up a high-end CPU and a high-end graphics card, suddenly you're going to start eating a lot of watts. So with the phase we're entering, you can see that having a high-built VRM is actually definitely preferable. But if you're stuck in a pinch and you want to put, if you've got an older motherboard and you want to drop a high-end CPU in there, at stock speeds, you'll probably be fine. Let me know what you think down in the comments below, because I don't know how I feel about this video, quite frankly. I'll be very interested to know what you guys think. Do you think this test was representative, or do you think the methodology just sucked? Who knows? Let me know. Genuinely curious. Thank you very much for tuning in, everyone. I hope you all learned something from all of this. And if you want to check out the description down below for my support links, including my Discord server, my Twitter, and my Patreon. Thanks a lot, and I'll see you next time. Bye for now.